We are the sun superheroes.
Our mission is to tell people about the amazing scientists who are studying the sun. Hi, my name is Emma. I have a question for you.
Hi, Emma.
Hi. One of the things we struggle with in the lab is coming up with metaphors to understand hard science. Do you know of a good metaphor or simile that can describe how hot the sun is and how violent a coronal mass ejection can be?
Okay. Yeah, metaphors are really good things for helping people to understand. So let's see. How about the sun being so hot? Well, first of all, its temperature is 1,000,000 degrees. This is the outer part of the sun. So when we talk about the sun, oftentimes we talk about the solar surface. It's not really a hard surface. You couldn't stand on the surface of the sun. It's a gas. So it's like a cloud. I mean, sometimes clouds are very thin and wispy, but sometimes you have one of these billowy cumulus clouds. It looks like cotton up in the air, and it seems like it has a sharp edge to it, but it's really not a sharp edge because a cloud is nothing more than water particles. In the same way, the surface of the sun isn't really like a hard floor you can stand on. But it's a place where the properties of the sun change, so it just seems like a surface. So at that surface, the temperature is 5,000 degrees. That's already really hot by our standards. But above it is the part of the sun's atmosphere that we call the corona. And the corona has a temperature of 1,000,000 degrees or several millions of degrees. So how do I help you understand how hot that is? Let's do this. Let's suppose that as an analogy, as a metaphor, we imagine walking a certain distance, and as we walk, the temperature is increasing. Okay? So if you were to walk the full length of your school, it's probably, something like 100 feet or so. Anyway, so imagine walking the full length of your school, and in walking that full length, the temperature increases from what it's normally like in the middle of winter to what it's normally like in the middle of the summer. So where are you guys from? I don't remember. What state are you in?
Pennsylvania.
Pennsylvania. Okay, good. That's perfect. So you do have cold winters and hot summers. So again, imagine you start walking, you walk the full length of your school, and the temperature increases from the cold of the winter to the hot of the summer. In order to keep walking and get to the temperature of the solar corona, you would have to walk across the entire United States, from coast to coast, walking from Pennsylvania all the way across the U.S., over the Rocky Mountains, all the way to California. And only then would you get to the temperature of the corona. So it is really hot. And let's see, you asked about coronal mass ejections and how much energy they have. Well, coronal mass ejections and solar flares have about the same energy. So let me talk about something called a nanoflare. The reason the corona is so hot is because there are lots of little explosions happening all the time. And each of these explosions is called a nanoflare. It's like a tiny flare. But even though these nanoflares, these tiny flares are very small by the standards of the sun, they're not small at all by human standards, because each one of these nanoflares is the equivalent of a 50 megaton hydrogen bomb. So the largest bomb ever exploded on the Earth, this was thankfully only done during tests, but the largest bomb we ever exploded, that's about the equivalent of one of these little tiny nanoflares. And a regular full-size flare, or a regular CME, those are the equivalent of about a billion of these nanoflares. So it's huge. So another even easier way maybe for you to understand this is the energy of a CME is enough to power all the electricity in the U.S. for 1,000,000 years. So if you could capture all the energy of a CME, you could power the electricity of the whole country for 1,000,000 years. That's a lot of energy.
You can talk. You don't have to be silent. You're allowed to go, wow.